Welcome you all. In this video, we will learn how to solve the circuit problem using mesh current analysis. So one thing first you need to see when you are trying to solve the circuit problem using mesh current, see to that your circuit is having voltage sources or current sources. If the problem is given with the voltage sources, then it is a pretty much straightforward. So either you can go to apply Kirchhoff voltage law for individual meshes and form the equation and you can solve. Otherwise, you can also form the matrix by looking at the component in the each of the mesh, right? So now we will take this problem. If you look at this problem over here, so this problem actually having all voltage sources. So and more specifically, you can see here this circuit having three independent voltage source. Independent voltage source means whose output voltage is always constant, whose voltage not going to be depends on the any other part circuit element quantity, right? So that is what independent voltage source, right? Now let's see when the circuit problems are given with independent voltage sources, how to solve using mesh current method. So when you are trying to solve using mesh current method, so the first step is to figure out the number of mesh. So as you can see here in this circuit, you can find totally 3 meshes. Am I right? So mesh is nothing but is a closed path which does not contain any other closed path within it. And you can look here. So we have totally 3 closed path, that is we have 3 meshes. So this I can take mesh number 1, this is mesh number 2 and this is mesh number 3. And once you decided the number of mesh, then you try to assume the mesh current which is going in a clockwise, and it is your assumption only, so it is better always to assume the current in the meshes going in a clockwise. And as you can see here in this problem, they already mentioned mesh current as I1, I2 and I3 and all are going in clockwise, right? So once you have done this, the next step you can apply Kirchhoff voltage law on individual meshes and you can form the equation, or else you can form the matrix straight away by taking each element in the matrix. So I'll go with the matrix formation method. So first I try to form the matrix, so that can be formed simply by using a Ohm's law. As we know from the Ohm's law, voltage is always equal to I times of R, and in mesh current method, current is the unknown quantity which we need to figure out. So I'm just making this equation as keeping unknown on one side. So I am rearranging this equation as like R times of I, which is equal to V. And now this can be made as a matrix. So here you can see that R is a resistance matrix of into meshes, and I is the current matrix and V is the voltage matrix. And the size of these matrices follow in this way. So always the size of the resistance matrix will be M cross M, where M is the number of mesh, and current matrix size will be always equal to M cross 1, and voltage matrix size will be always M cross 1. Okay, and as we know that here you can see that resistance matrix we're having size of M cross M. For this problem, the number of meshes is 3, so which is going to be a 3 cross 3 matrix. So if I put it in a matrix form, then this is what the general format of resistance matrix. So 3 cross 3 means totally 9 elements. So I'll go with the first element is R11, which is nothing but the sum of resistor in the mesh 1, then R12, then R13, where R12 is the resistance which is connected between mesh 1 to 2, R13 is nothing but resistance which is connected between mesh 1 to 3. And one more thing you should note here, and as I said already, we are going to assume in all the meshes current is going in clockwise. And if you consider the clockwise direction, as you can see here, This is a 50 ohm resistor which is common for mesh 1 and mesh 2, and in that 50 ohm common resistor there are two currents, right? You see that I1 current as well as I2 current is flowing through this 50 ohm, uh, based on the direction we assume, and these two currents are opposite to each other. So for that reason, always the common branch resistor symbol has to be kept as minus. So when I put this in a matrix, common resistance will be always kept as a off diagonal element. So I have to keep all off diagonal element is minus over here. And please remember, this minus is fact that we are taking all the currents are in clockwise. Okay, so off diagonal minus R12, this is also off diagonal minus R13. Then second row I can write minus R12 because this is also off diagonal, which is nothing but resistance which is connected between R21, that is mesh 2 to mesh 1. Then R22, then minus R23. Again 23 is a common, right? So R23 is nothing but resistor connected between mesh 2 to mesh 3. Then next third row minus R31 minus R32 or 33. So you can see here R11, R22, R33 I kept positive, whereas all other off diagonal element minus. As I said, the reason why we are keeping all of off diagonal minus, because we are taking all the currents are clockwise, which makes in a common branches, that is in a common resistor, the currents are opposite to each other. Okay, this is the resistance matrix. Then I have to keep a current matrix. Current matrix we have a three mesh. So mesh 1 current I1, mesh 2 current I2, and mesh 3 current I3. Then I'll put a voltage matrix. So voltage matrix, you can see mesh 1 voltage V1, mesh 2 voltage source V2, and mesh 3 voltage source V3, right? And this is the general matrix format for a three mesh problem. And as you can see here, this is the resistance matrix, this is a current matrix, this is a voltage matrix. So whenever the problems are given only with the voltage sources, even if it is a dependent or independent voltage sources alone, then it is very easy for us to go with this matrix form. But please remember, when the problems are given with the current source, you need to deal in a different way. Right, now I try to find out each component and put it in the matrix. Okay, let's start with forming a resistance matrix first. So R11, as I said, is nothing but the sum of resistor in mesh 1, and you can see here in mesh 1 we have a 1, 2, and 3 resistor. So 60 plus 30 plus 50. So if I put, I'll be getting this as 140, right? Then 1, 2, which is nothing but the common resistor between mesh 1 to mesh 2, which is a 50 ohm resistor. So again it is off diagonal, so I have to keep a minus 50. Then 1, 3, which is nothing but the resistor which is connected between mesh 1 to mesh 3, which is nothing but 30 ohm. So again it is off diagonal, so I'll go with the minus 30. Then 2 1 minus 50, and 2 2 is nothing but sum of resistor in mesh 2. You can see in mesh 2 we have 3 resistor, 50, 40, and 10. So which is going to be 100, right? Then 2 3, which is nothing but the resistor which is connected between mesh 2 to mesh 3, which is a 40 ohm. So I'll put minus 40, right? And then we have 3 1 3 1 again, which is nothing but resistor connected between mesh 3 to mesh 1, which is a 30. So again it is off diagonal, so I'll keep minus 30. Then 3 2, which is nothing but resistor connected between mesh 3 to 2, which is a 40. So again off diagonal, so I have to go with a minus 40. Then 3 3 is nothing but sum of resistor connected in mesh 3. So again 3 resistor, 40 plus 30 plus 20, so 70 plus 20, 90. So this is the resistance matrix. Okay, and current are unknown. Let's keep I1, I2, I3. Then about voltage, now you can see in mesh 1, right? In mesh 1 we have two batteries, right? 100 volt and 20 volt. Now let's take this. So let's take first a 20 volt, and you can see that 20 volt having terminal plus and minus over here, and in that you can see the current is coming from plus to minus. So whenever you see in a battery terminal, current is flowing from positive to negative. Positive you can assume like a higher potential, negative you can assume like a lower potential. So whenever current drop from higher potential to lower potential, you take that battery voltage as minus. So I'll go with the minus 20 and apply the same thing to the 100 volt battery. You can see in 100 volt, you can see that the current is going from minus to plus, so lower potential to higher potential. So here it is getting increase, so this can be taken as rise. So I have to take this as plus 100. So keep this in mind whenever you are seeing the battery sign. uh, See to that how the current is going in a battery terminal. If it is from plus to minus, it is like high to low drop, take a minus sign. If it is from minus to plus, right, like a minus to plus, so it is like a rise, you take a positive sign. Okay, this is for mesh 1. Then let's we take for mesh 2. So in mesh 2 again we have a two battery, right? So we have this 20 volt battery and also 50 volt battery, and again I should apply the battery sign. And let's take for a 50 volt first. 50 volt, you can see this is a direction, so it is going from minus to plus terminal, so it is like again a rise. Okay, so rise means we should take a plus 50. Then about in 20 volt I2 current is going up, right? So when I2 current is going up, it is also going from minus to plus, right? It is also a rise, so I should take a plus 20. Is it clear? Right, that's it. Now let's we check mesh 3. So in mesh 3 you can see there is no voltage source, so I take straight away that as 0. Okay, that's it. And this is the voltage matrix. Now I just simply apply the matrix multiplication and try to write the equation. So you can multiply this like 140 I1 minus 50 I2 minus 30 I3, which is equal to 80. This is equation number 1. Then also we have minus 50 I1, so minus 50 I1, next plus 100 I2. Okay, plus 100 I2 minus 40 I3, right? Minus 40 I3 equal to 70. So this is second equation. Third equation, minus 30 I1, so minus 40 I2, then plus 90 I3, which is equal to 0. So this is equation number 3. So actually our question is we should get the mesh current I1, I2, I3, right? So let's solve this equation and find I1, I2, I3. After solving this, so you'll be getting a answer as I1, which is equal to as 1.65 ampere, and I2 2.12 ampere, and I3 1.5 ampere. Alright, so this is the miscurrent. And also they ask us to figure out voltage across 40 ohm. So that can be find by using the Ohm's law, and you can see that 40 ohm is there in actually between mesh 2 to mesh 3. So whenever you are trying to find out voltage across any resistor, okay, so you go with the basic Ohm's law formula. So I can say that voltage across 40 ohm resistor is nothing but the current through 40 ohm and its resistance. And as we can see here in the circuit, The 40 ohm is a resistor which is connected to common between mesh 2 and mesh 3, which means this is going to take I2 and I3 current, and based on the direction we assume both currents are opposite to each other. So in that case I can say that the current through 40 ohm is nothing but I2 minus I3, right? Into the resistance of a resistor is actually 40, right? So now you can apply that I2 minus I3. I2 is not, because you know that I2 is nothing but 2.12 minus 1.5 into 40. So now you solve. So 2.12 minus 1.5 will give 0.62, and if you multiply that with 40, you will be getting 24.8 volts. So this is the voltage across 40 ohm resistor. Thank you.